This is Dr. Kavita Singh, Associate Professor in Institute of Aeronautical Engineering. So today we are going to discuss a topic called as energy interactions with Earth's surface features. So in the previous lecture we have just discussed about the energy interactions with atmosphere. So what happens when the energy interacts with the atmosphere, we have discussed in the previous lecture. So actually what happens is, like, when it interacts with the atmosphere, there are two mechanisms which take place, that is absorption, and another one is scattering. So scattering mechanism is the mechanism like it scatters when it interacts with the atmosphere due to the presence of dust particles, due to the presence of different gases. Either scattering will take place, either absorption will take place. So that energy interacts with the atmosphere later when it reaches to the ground. After passing through the atmosphere, it has to reach to the ground. So when it reaches to the ground, then what happens with the energy and how it is helpful for remote sensing purpose. So in the previous lecture we have discussed, like, there is a atmospheric window. That window is called as that is a visible region from where the radiation can pass through, and from there it reaches to the ground. After reaching to the ground, what happens with that particular energy and how it is helpful in the remote sensing process. So this we are going to discuss today. So first thing, we will be discussing about energy interactions with the Earth's surface features. Like, what is energy? That energy we are talking about here about sun. Sun is the source of energy. So radiation, whatever radiation we receive on the Earth's surface, that we receive from the sun. So the sun radiation is helpful in the remote sensing process. So in this remote sensing process, only we are able to do the passive remote sensing, because it depends totally on the solar system. So whenever the sun radiation is available, then only we are able to do this passive remote sensing. So when it interacts with the Earth's surface, suppose this is the sun and this is the atmosphere. This is the atmosphere. So when it falls on the ground, before it reaches to the Earth's surface, when it is reaching to the Earth's surface, directly 100% of the radiation will not reach to the Earth's surface. What happens? Due to presence of gas molecules, dust particles, this energy, out of 100%, around 50% will be scattered. 50% will be scattered and either absorbed due to presence of gas molecules and dust particles. So through the electromagnetic region, so when we consider this region a visible region, in this region, when we see this window, which is 0.4 to 0.7, from this window, which is called as atmospheric window, this window will allow the radiation to pass through and reach to the Earth's surface. So now, out of 100% of the radiation, only 50% of the radiation is reaching on the Earth's surface feature. So when it reaches on the Earth's surface feature, it has to interact with different kind of objects, different kind of features, Earth surface features which are present on the Earth surface, like physical features. So in physical features are like hills, mountains, we have river, or we can say water body, or vegetation, or settlement, different kinds of features. Whatever we see on the ground, that all type of feature, when this energy falls on these all features, it either absorbs, either transmits, either reflects. So these three things happen. These are the three mechanisms which happens when it reaches to the Earth surface feature. So Earth surface feature will be the target. Always it is a target to the energy for remote sensing process. So remote sensing process. So in our target we have these all features which are present on the earth surface. So when it falls, so either due to the presence of water vapor, to the presence of water, to the presence of let us say if it is a black body or if it is a light surface or something like smoothness, roughness, different types of texture will be present on the earth surface feature. We have different settlements over earth surface feature, vegetation, different colors we have dark green, we have light green, we have little more lighter green, or something like dried forest will be there. So these all features will behave differently when this energy falls on the earth surface feature. So there are three mechanisms happens when it falls on the earth surface feature, that is absorption, transmission and reflection. So there are three forms of interaction that can take place when energy strikes or is incident upon the surface. These are absorption, transmission, and reflection. So the total incident energy will interact with surface in one or more of these three ways. One or more of these three ways. So the proportion of each will depend on the wavelength of the energy and material and condition of the feature. So absorption, what is absorption? Absorption occurs when radiation is absorbed into the target. So when it occurs, absorption will take place when there is a water body present or something suspended solids are present or water content present in the soil or more water present in the vegetation. So these will take place. The energy will be absorbed in these kind of feature, or either features are very smooth features or they are black bodies. So they will absorb the heat, they will absorb the radiation. These things will happen when these kind of things are present on the earth surface. When does the transmission happen? When then does the transmission happens? Transmission occurs when radiation passes through a target. When the radiation passes through a target, like it can reach on the earth surface and it will pass to the another feature. That is called as transmission. It transfers its radiation to the other feature. That is called as transmission. Then reflection. Reflection, when it happens, reflection occurs when radiation bounces off target and it is redirected. So what happens when this energy falls? So it reflects back. When it reflects back, when there is a rough surface, okay, when there is a rough surface. So rough surface means it's like the texture of the surface, the texture of the soil, or the type of the topography, either it is a mountain, either it is a hill, either it is a plateau, or either it is the texture of the soil is very rough, or these kind of features will reflect back, or it is redirected from its path. Either it is reflecting, either it is reflecting. That means it is bouncing back. The absorption will take place when the texture is smooth. So it's smooth texture, the absorption will take place. Tough texture will be just reflecting back to the atmosphere. So when it reflects back to the atmosphere, the satellite present in the space is having a sensor. So that sensor will be capturing the reflected energy. It will capture the reflected energy. Okay. So this reflected energy is captured by the sensor, and whatever reflected energy it captures, that is sent back to the receiver station. Is sent back to the receiver station. So receiver station can be like ISRO, the organizations which are controlled by the ISRO, like National Remote Sensing Center. They will be having the receiver station where these all informations are received over here. So this receiver station will give the products out of it in the form of satellite images or in the CDs in the tape. So these all information again we will get in the form of an image. So in that image, however the reflection has taken place, that will be appearing in the satellite image. So either reflection if it takes, either transmission, absorption, that depends on the type of the features which is present on the Earth surface. Now coming to this figure. So in this figure you can see first when electromagnetic energy is incident on any feature of the Earth's surface, such as water body, various fractions of energy get reflected, absorbed, and transmitted. So when you see this figure, energy interactions, so this is a surface where we can see there is a water body present here. So when it falls, that is E1 is equal to ER plus EA plus ER. So EI is the incident energy, ER is the reflected energy, EA is the absorbed energy, and ET is the transmitted energy. So is equal to incident energy. Okay. So when it falls on the Earth surface, so here is the incident energy. So reflection is taking place, transmission is taking place, absorption is taking place. This is happens when it is falling on the ground surface region. Now here we can see this is the sun rays falling on the ground, Earth surface. So here reflection is there, absorption, transmission means transferring from one object to the other object. So mostly what happens, absorption or reflection take place, and that energy is only recorded in the electromagnetic spectrum, that is only recorded in the region and by the sensor, and which is sent back to the receiver station in the form of satellite images and information. Now here the same picture in different way. So here is our incoming radiation, transmission is taking place, reflection is taking place, somewhat scattering with the atmosphere, and here absorption is taking place, reflection is taking place. So due to presence of different types of object, it behaves differently. So according to the principles of physics, it is known as ER by EI to EA by ET and ET by EF. So a measure of 1 means 100% of the incident radiation is reflected off the surface, and the measure of 0 means 0% is the reflection. So it is just shown in 1 or 0. So when we get a image, a digital image, it is represented, the reflection of the energy is represented in the form of either 1 or 0. So if it is showing 1, means 100% of incident radiation. Okay. So when it is showing 0, that means 0% is reflected. 0% is reflected. So this is how it is represented in the image with hundreds or zeros, and that is like measure 1 or 0. So spectral reflectance curve. So based on this, the result will be in the form of a spectral reflectance curve. So spectral reflectance curve is a basic assumption made in the specific target has an individual characteristic manner of interaction is described by spectral response of a target in a particular wavelength region of electromagnetic spectrum. So now it's a reflectance curve means we have a graph here where it will show reflectance. The coming slide will understand better reflectance, and here we'll be having regions. Okay, so it will show us that if it is a soil, for example, if it is a soil or water or vegetation, so how much reflection a soil is having in which region. So there are different regions here. We start from visible, then we have infrared region, then we have a near infrared region, then mid-IR region, then microwave region, then television region. So we just use this spectral reflectance curve right from the visible region to the radio regions, because before this we have this short wavelength radiation, short wavelength region, which is totally waste for the remote sensing. It is not at all helpful for the remote sensing. That's the reason whenever we talk about the reflectance curve, Reflectance curve means it will show the curve like this. Either it is reflecting, either it is absorbing. So that all depends on the spectral response of a target. What is a target? What is a target? Target is our objects. Objects on the Earth surface. Object on the Earth surface is a target. Okay. Now this is what I was talking about. So here we have this spectral reflectance curve. Reflectance curve means it will show you which feature is reflecting in which region, and it's like a peak and valley. Peak and valley configuration. Peak and valley configuration. It will show us about the peak and valley, where it is reflecting, where it is falling down. So like we have here few of the examples here. Like we have clear water, soil, rocks, healthy vegetation. So clear water, soil, rocks and healthy vegetation. These four types of features which are present on the Earth's surface. What happens when it falls on the Earth's surface? So when this energy falls, suppose here is the sun, when it is falling on the ground. So if we talk about the clear water, so this black color, what you can see here is clear water. Blue color, sorry. This blue color we can see the clear water. So here the clear water is, it is absorbing. So it is falling down here in 0.4 to 0.8 region. So it is absorbing. There is no reflection. When you talk about soil, now soil we can see here absorption is more in the visible region, whereas reflectance is more in the infrared region and near infrared region, radio wave region, microwave region. So reflectance is more here. When you talk about healthy green vegetation, so healthy green vegetation you can see here 0.4 to 0.7. It is just absorbing. The less peak we can see, but the maximum peak where we can see here is infrared region. Infrared region, it is highest peak. Then again it is falling down, again falling down, falling down. That means in the microwave region and radio region, it absorbs. So it will not reflect. So it will only reflect in the infrared region. So in infrared region, it is the highest peak of reflection. That's the reason the vegetation, when we see a satellite, when you see a satellite image, always the vegetation will appear red in color. It will appear red in color. So vegetation appearance due to the presence of chlorophyll, what happens? The reflection will be more in the infrared region. That's the reason that red color will appear in our images. Now when we see rocks, so rocks is in visible region, it is less reflecting. Near infra, it is more reflecting. Then SWIR or radio region, it is reflecting more. So this curve is based on the type of the feature, type of the object which is present on the Earth surface. Now healthy green vegetation we have seen lot of, it is having more peak and valley configuration. You can see there is lot of peak and valley. Like here it is a small peak is there, again high peak is there, again down, up and down, up and down. That happens due to the presence of leaf color. So wherever we see the green leafy color, because vegetation will not be every time evergreen, dark green. It may there will be a variation in the color, like it has a dark green color, it has a more lighter color, or something. The vegetation will be dried. Based on that, the reflectance curve will take place. So this is the graph of reflectance curve, where we can see wavelength in micrometers. Here it will show you the reflectance percentage, how much percentage it is reflecting in the which region. So as a result of the energy when it interacts with the Earth surface feature, as a result it will give a reflectance curve to show the type of the feature. So with the help of this reflectance curve, we are able to identify the type of the feature, presence of water content in that particular feature, and how it is appearing on the Earth surface. This all we can just identify. Now, energy interactions with Earth surface features play a crucial role in various natural processes environmental phenomena. This interaction involves the exchange of energy between incoming solar radiation, Earth surface, atmosphere. Here are some key interactions with Earth surface feature, like absorption will take place. So, what is absorption? So, the different surface features absorb solar radiation to varying degrees based on their composition, color, and texture. Dark colored surfaces such as forest, oceans, asphalt absorb more solar energy, and light color surfaces such as ice, snow, sand. This absorption heat surface contributes to local temperature variation. So wherever the dark color objects will be present, there we will see uh, due to presence of the dark color such as forest, ocean, and asphalt, more energy will be absorbed. Now, reflection surface features reflect a portion of incoming solar radiation back into the atmosphere. The amount of reflection known as albedo. The amount of reflection is known as albedo. Whatever energy is reflected is called as albedo, and that depends on the surface reflectivity. Depends on the surface reflectivity. Surfaces with high albedo, such as ice caps, clouds, reflect more sunlight, while surfaces with low albedo, such as forest and water bodies, absorb more sunlight. Energy transmission refers to, and what is energy transmission? It refers to the process of transferring energy from one location to another. So this can involve various forms of energy such as electrical energy, mechanical energy, thermal energy, and more. So the methods of energy transmission depends on the type of energy being transferred and distance over which it needs to be transmitted. So here are some of the common methods of transmission, like conduction. Conduction is one method of transmission. Like energy is transferred between energy surface, earth surface, and lower atmosphere. It is transferred between earth surface and the lower atmosphere through conduction. So the direct transfer of heat through a molecular collisions, surfaces with high thermal conductivity such as soil and rock, and transfer heat more efficiently, and then surfaces with low conductivity such as air and water. So this is one of the example of transmission. Now we have convection. Convection currents in the atmosphere and oceans transport heat vertically and horizontally, redistributing energy across the Earth's surface. And the example of what we see here is when the warm air is rising from the Earth's surface, it creates connective clouds. Whenever the warm air rises, it creates a connective clouds and weather patterns. While ocean currents transport heat from equator towards the pole. So this is one of the example what we see of the convection. So convection currents in the atmosphere ocean transport heat vertically and horizontally, distributing energy across the Earth surface. So these are all references which we have gone through for this energy interaction with the Earth surface feature. So in the previous lectures also we have already discussed, like for remote sensing and GIS, the very good book what we can get is in Anjiradi, remote sensing and GIS by VS Publications. So when you find out the fourth edition of this book, you will be finding more content about the more case studies about this kind of topics. So you can just go through this book, and we have this fundamentals of remote sensing by George Joseph. This also you go through. LR Narayana, remote sensing and its applications. We have another good book for the remote sensing process. Then we have S. Kumar, basics of remote sensing and GIS. We have Tan Chan, which is GIS TMH publications and corporations. Then we have remote sensing and GIS by B. Bhatia, Oxford University Press, New Delhi. So these are all references which we can go through, which you can go through to find out the more content and learn more about the remote sensing and GIS. I hope you understood about energy interactions with the Earth surface feature. So Earth surface features is a target for the passive remote sensing. When it interacts with the Earth surface, the energy either it reflects, either absorbs, either transmits. So these three things will happen when the energy interacts with the Earth surface feature. In the previous lecture, we have seen that when the energy interacts with the atmosphere, scattering and the absorption mechanism will take place. So when it interacts, these are the things happens on the Earth surface and in the atmosphere. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.